In this video we're going to derive the three compound angle formulae, and in the following video I will show you how we can use those formulae in various situations. To derive our equations we're going to use two right angled triangles, one with the angle alpha and one with the angle beta, and we're going to join them together in a special way. So here's our right angled triangle with angle alpha, and then off of the hypotenuse of this triangle we have another right angle triangle where we have angle beta. We're then going to drop a vertical from D, or a perpendicular from D down to the line AB. So we've got another right angle here which gives us this right angle triangle. We're then going to draw a line from C perpendicularly to this line, which actually gives us a right angle triangle here as well. Now this line of course will be parallel to this line, which means if this is alpha, then this angle here must be alpha. Now that means this angle here must be 90 minus alpha, and if that is a right angled angle and that's 90, that means this angle here must be alpha also. Okay, so let's now calculate or derive the formula sine A plus B, or alpha plus beta. So if we look at this triangle here, we can see that sine alpha plus beta is going to be the opposite over the hypotenuse, or the opposite is going to be FE and DF, so it's those two added together over 1, and that's why we pick 1 to make that simpler. Okay, so then we've got sine alpha. So using this triangle here, we can say sine alpha equals CB over the opposite over AC, the hypotenuse. But CB and FE are the same, so we can actually write it as FE over AC instead. And if we rearrange that, multiply by AC, we get FE equals AC sine alpha. Okay, what about cos beta then? Well, here's beta, cos it's going to be opposite, so it's going to be adjacent over the hypotenuse, so that's just AC, and we want AC in here, so that means FE equals sine alpha cos beta. So we've got the first part of our formulae. Okay, what about sine beta then? Sine beta, beta is opposite over hypotenuse, so that's just DC. What about cos alpha? Well, cos alpha is going to be the, and we're going to use this triangle here now, is the adjacent over the hypotenuse. And so that gives us cos alpha equals df over dc, but we already know that dc is sine beta. So if we cross multiply, we get df equals cos alpha sine beta, and then if we put this into here and this into here, we get the well-known formula for the compound angle sine alpha plus beta. Okay, so let's derive the formula for cos of A plus B, or in this case here, cos of alpha plus beta. Well, cos of alpha plus beta is going to be the adjacent over the hypotenuse, AE over 1. So we want cos alpha, so cos alpha is going to be the adjacent, AE plus EB, over the hypotenuse, which is going to be AC. Cos beta from this diagram is going to be the adjacent AC over 1. Now if we join these three things together, so we can, instead of AE we can put cos alpha plus beta, instead of AC we can put cos beta, and we get this formula here. And then if we cross multiply and bring the cos beta up and then rearrange, we get this formula here. So we need something for EB here, which we can see EB and FC are the same. So we get sine beta. Sine beta is going to be DC over 1, and then sine alpha, we're using this triangle here, is FC over DC. So that's going to give us FC equals sine alpha sine beta, just by putting this here and cross multiplying. But because FC and EB are the same, we're going to get cos alpha plus beta equals cos alpha cos beta, change of sign, sine alpha sine beta. Okay, so let's calculate the formula for tan alpha plus beta. So we already know the one for sine alpha plus beta, and we already know the one for cosine of alpha plus beta, and we know that if we divide sine by cosine we get tan, so we get this formula here. Now this one is really straightforward. What we're going to do is we're going to look at these four terms here, this one, this one, this one and this one, and every single one of them we divide by cos alpha cos beta. And you can see if we divide this first one by cos alpha cos beta, the cos betas cancel and we're left with sine alpha over cos alpha, which is going to be tan alpha. This one, when we do the division, the cos alphas cancel out, so we're left with a tan beta. This one cancels out altogether, so we're left with 1, and this one there's no cancelling out at all, but we've got sine alpha over cos alpha for tan alpha and sine beta over cos beta for tan beta, and we get the formula that we've been looking for. I know that video was quite long, but it's really important we understand where our maths comes from. There are no questions with this video, but in the following video, part B, I'll show some applications of the compound angle formulae, not all of them by any means, and I'll put a question sheet to go with them so you can test your skills. Stay in field with Winfield.